Hey friend, welcome back to the channel. Today we're going to cover and talk about NumPy, which is a Python library that is widely used to analyze large volumes of numerical values and arrays. And I'm going to show you here step by step. So we're going to go through the fundamentals. We're also going to apply it in real world scenarios so that you can get a grasp of the basics, but also how to use them in your work. And also we're going to talk about when to use pandas and when to use NumPy, and when is it really interesting to use NumPy over pandas in your work. Okay, so here we are now on my computer. We are on VS Code. It's the IDE that I use for my coding projects. And here you see that we have it split into two main sections, the fundamentals and applying on a real world data set. Here I have a brief definition of NumPy, which is basically, as I said, the library to work with large sets of numbers, and we can do a lot of mathematical operations and also statistical operations, which is very interesting when you dive more into the world of data science and machine learning. You have to use NumPy and you will use it extensively. So first, if you haven't installed NumPy, you just do pip install NumPy. So you just go to the terminal and you write pip install NumPy, so that you have it installed in your environment in here. So we're using a Python environment here in VS Code. And then you can just simply import it by just calling import NumPy as NP. And this NP is just an abbreviation. So when you call it in functions, you don't have to call NumPy fully. So as you can see here, np.array, np.mean, np.median, all these things, you can just use NP as an abbreviation instead of NumPy. And you can do that obviously for all the other libraries as well. Here we have two arrays. One is a 1D array. It's basically a list of numbers. And the second one is a 2D array, which is a matrix. And here we have 3 rows and 3 columns. And to create them, we just do np.array and we give the value. So here we're just creating a sample array ourselves. And if we print them, we'll see that array number 1 is basically a list of numbers. And array number 2 is a matrix, 3, 3, which is 3 rows, 3 columns. Always starts with the rows, then the columns. So if we dive into the fundamentals, first we'll look into basic information. So if we want to look at the shape of the array, or if we want to look at the size or the type of the value that is inside the array, we can just use this basic Python code, which is basically array.shape, array.dtype, and array.size. Okay, so for the first array, we can see that this one is a one-dimensional with 5 values. We can see 5. The second one is a matrix of 3 rows, 3 columns. We can see the type integer, which is numerical. We can see the size, and we can see the number of dimensions with ndim. So this is basically for you to just get around the type, the shape, and the size and all these things, which is very basic. Then we can look at indexing and slicing. So here, let me bring these closer to us so we can have a look. So here, if we want to just get the first value of the first array, we do 0. 0 basically is the first value, then it's 0, 1, 2, and so on. If you want to get the second value, you'll do array and 1 in between brackets. If you want to get a set of value, like a slice of elements, you do a two dots separation between them. So you can see here 1 to 4, which is from 20 to 40. If you want to access a specific row and a specific column, then you can split them via comma. And if we run this, we can see, for example, this one, it will give us the first value of the array, which is 10, array 1. This one will give us from the first one to the fourth, 20, 30, 40. Here, this one will give us here the row number 1, as we can see here in array 2, row number 1. And then it gives us column 2. And this one here, we go to row number 1, and we always remember that we start from 0. So row number 1 will be basically, this is the row 0, this is the row 1, and then we go into column 2, so 0, 1, and 2. So we get the number 6, and this one, it gets us from the row 0 and 1, so the first 2 rows, and then we get the column from 1 onward. So it gives us 2, 3, and 5, 6. This is just basically how we can access information within arrays. It can be useful sometimes when you're exploring. And here, useful methods. So this is more of the mathematical, statistical values that you use usually in NumPy. So you'll find the mean, the median, the standard deviation, the minimum, the maximum, the sum, and you find them all just by using NP dots, and you call the method. We see the mean, we see the median, and all these things. And you can get them just like this in a very simple manner. And this is very useful when you do machine learning and statistics to get these values that are very useful in your analysis overall. We look here at elements of operations, and this is basic, just arithmetics, you know? We do the plus, the minus, division, square root, all these things. And you can basically just do them as you'll basically do mathematics if you're working in Excel. So let's say array 1, and we want to add 10 to the whole array. We just do array 1 plus 10. If you want to multiply the whole array by 2, we just do multiply by 2. And if we do it in here, we can see that all the array 1 was, we have 10 added to it, and here we have it multiplied by 2, here we have it squared, and so on. So basic mathematics and statistics that you would usually do in Excel, you can do it as well with NumPy. Here, it's more to create arrays. So we have methods to create arrays full of zeros or ones, or identity is the one that has diagonal all ones, and we can run them in here to see. So an array of zeros, you can create it basically by just doing how many rows and columns you want in it. Same for arrays with ones, and identity, as you can see here, is the one that has ones in diagonal. There will be cases where you can find these helpful. And this one here, NP random, is for us just to generate a random matrix. We ask NumPy to generate it for us. We just say we want it to take numbers from 1 to 100, random numbers, and we say 3 rows, 3 columns. And you can see here that it generated for us this matrix. And yeah, that's how we can create matrices yourselves. If you need to have identity, 0, 1s, or you create a random one, if you want to just do some testing, we're going to do that later. If we jump into applying on a real data set, here you can see I called pandas as well. So pandas will help us to work with data frames. And here is just for me to be able to see all the columns and all the rows. I've put 500, but usually you will rarely find a table with 500 columns, but it's just for me to be able to see all the columns. So here I just went and I brought this data set here, Premier League, the season 2024 and 2025. So in here, I am just uploading a CSV file with the Premier League data games of this year, 2024-2025. And where you can find it is just on this website here, football-data.co.uk/data.php. And you can just go in here, and on the right side, you can see, for example, here, England. You click on England, and here, season 24-25, Premier League, and it will download the file for you. So that's exactly what I did, and that's the file that I'm using now. So you can do the same. I just renamed it because the name was e0.csv. I just renamed it into this, so you can follow up with me as well. I will add this all to GitHub, so you can find it in the description below. So as we can see here, we just printed 2 rows, and we can see that we have all this data on games, and we have the dates, the time, who is the home team, the away team, the full-time, home goals, away goals, and so much data that can be used. We obviously won't focus on everything because that's not the main goal of this. We just want to show you how we can use NumPy in here as well. So here we went and we took 2 columns, the full-time home goals and full-time away goals, and we turn them into NumPy arrays, and then we just do the mean value of them so that we can get the mean value of the home goals and away goals for the whole season so far, for all the games played. So if we run it, we can see that the average home goals is 150 goals per game, and the average away goals is 145, which is a little bit lower than the home goals, which kind of makes sense. Usually teams at home, they are able to score more than when they play away. And this one here is just basically for us to get just 2 values after the decimal, after the dot in here, just so that it looks cleaner and we don't have like a 10 numbers after it. And here you see we use the mean value, and we're using now a real data set, so something that you can encounter as well while working with NumPy. Here we're gonna do the standard deviation. With NumPy, you can do all the statistical calculations and arithmetics. So we did the mean. Here we can do standard deviation. So we want to see by how much we deviate from the mean, and that's the whole purpose of using standard deviation. And we can see here 1.25, 1.23. Here we're just gonna plot a histogram where we're gonna compare the home goals to the away goals, and we can see the distribution. And here It's just a way for us to visualize the things that we were analyzing via NumPy using Matplotlib, which I will make a video on it as well. So stay tuned and subscribe to the channel if it's not yet done. I'm going to cover Matplotlib, Plotly, Streamlit, and so many other Python libraries as well over time. Here we're going to do some filtering and Boolean indexing. So Boolean usually is where we have either a yes or no or 0 or 1 values. Here again, we chose 2 columns. We've put it in a variable called home goals and away shots. And this one here, we just turn them into NumPy arrays. So when we work with pandas, this is a data frame. It's like a table style. It's a data frame. So if I want to get the data from this column, I get it in a tabular format. But when I do dot to NumPy, I then switch it into a NumPy array. So if I run this, for example, and if I go and look into this home goals, we're going to see that this home goals now is an array. An array looks like this. It's just basically a list of numbers. And it's so much faster to make calculations with arrays instead of doing them tabular format with data frames. So here, basically what we did, we just basically put a condition. If home goals are above or equal to, and away shots are above 15, and we're just basically slicing the data and filtering the data to only keep whatever we want. We don't want to keep everything. We want to keep only home goals where it's above 2 and the away shots are above 15. You know, so it's called filtering and slicing as well. We can now look at vectorized calculations with NumPy. And this is basically a faster way of doing a Python loop, and it's cleaner and easier, and it's more efficient because NumPy operates on a C-level operations under the hood. So it's way faster than just using traditional Python loops or pandas. So here, for example, we're looking at total goals per match. And what I'm doing here is I will compare it to pandas. You can see here we have this percentage time it, and this one is basically going to time both operations. The first one will be with pandas, the second one will be with NumPy, and we will see how faster the operations are overall. And this is just to show you that NumPy can be super fast and super nice to use, and especially when the dataset gets bigger. So here we can see that we have 27 microseconds using pandas, whilst we have 305 nanoseconds using NumPy, which is 90 times on average faster. We can see it's 92 times faster for this operation as well. And these are very basic mathematical calculations that we're doing here, but we can see the power of NumPy. So what I did in here is I went and I tested it on a 100,000 rows sample. So I just came here and created this sample just by using a randomizer, np.random. We just create columns and just fake data in here so that we can redo the same calculations and see if NumPy performs better or not. And we basically recreated some of the same columns that we had in the football dataset. And then what we do here, we just look and we see that we have 100,000 entries, which we created now, 100,000 rows, and we can see what it looks like. This is just looking at the first 5 rows of the dataset. And then we just do again one of the same calculation as we did before, and we're gonna see that NumPy operates way faster than pandas. Again, here we can see that NumPy operates roughly 50 times faster than pandas. Obviously, this is a sample of 100,000 rows, but the values are quite simple to put in here, so it's not a very large file. But the bigger the file and the more complex the calculations that you do, and the more you'll see that NumPy is very efficient. But it was just for me to show you power of it. So here we come in here into aggregations and summary statistics using NumPy, and here are most of the ones that you're going to use. You know, the mean, the median, the minimum, the maximum, the variation, the variance, the standard deviation, percentile, 25%, 50%, 75. I've put them all in here so that you can use them. You can redo this exercise yourself as well. And hopefully if you do the hands-on, you'll see that how powerful it is and how also simple it is to use. It used to feel daunting for me when I just started using NumPy as well. And you can find the equivalent in pandas. You just do df.describe, which will go and take the data frame and it will give you all the statistical values of the numerical columns. So the columns have to be numerical, and you will see they have the mean, standard deviation, minimum, maximum, and most of the things that we did on NumPy as well. So you'd say, why not use pandas and use NumPy? It's because in some cases, NumPy is way faster, and the more complex it gets, and the better NumPy becomes as well. But Pandas definitely has a huge place in here, and you'll see later that we can combine them both. It doesn't mean we can use one and not use the other. They can be used, both of them. And Pandas anyways is built on top of NumPy. So that's something good to know. In here, for example, we just want to get the unique values for the home goals when home goal equal to 0 or to 1 up until 7, and we can see how many times it appeared on the data. This could have been a loop condition that we can do also using Python and Pandas, but in here it was done very quickly using NumPy as well. Just going through the column and trying to find the unique value and the number of iteration or the count that we have in it. If we look at this one here, in this one here, we basically just picked up 4 different columns, and we just did the basic statistical operations that we did before: the mean, the standard deviation, and also the minimum and maximum values, and we can see them appearing in here. So it's interesting if you have a project and you want to know for some specific features or columns, what are the minimum, maximum, standard deviation, and mean, so they have a quick picture, an idea of what's going on under the hood in here. So here we're going to cover using Pandas and NumPy together, and sometimes that makes it super powerful. So for example, here we convert columns to NumPy arrays when you need speed and math. That's what we said, the power of NumPy. So in here, we took a column basically in the data frame, we turned it into a NumPy array, and then we did the mean value of it. This is how we saw it earlier. Here, we're going to use NumPy for conditional logic, then assign in Pandas. So we see in here that we're creating a new column, and we go use this method here, np.where, and we go to the column that is initially in our data set, and we just put a condition. We turn it into a NumPy array, and we put when it's above or equal to 3, it's either yes or a no. And then we have created now this column. If we can showcase it, let's say we do it's just df.head2. And if we go back in here, we can see that this column was created for us in our Pandas data frame using NumPy with the condition that we've put that it has to be above or equal to 3. So that's powerful. We can see that we can combine Pandas and NumPy in the same calculations and the same code, which makes it super powerful. For example, here we can do NumPy for massive calculations or batch calculations, and Pandas for readability, because we're very familiar with Pandas and the way data frames work. We can still use NumPy methods, put on conditions, and then we can also, here for example, this one, we did that we wanted the column HS to be divided by the column that has the full-time home goals, So it's a combination. It depends on what you prefer to use and how do you prefer to work, but it's always good to be aware of both of them and know where to use them and what are the advantages of using NumPy. So here in the conclusion, we can see that NumPy and Pandas are both used for data exploration and analytics. And when should we use NumPy? When the performance matters for fast mathematics and vectorized operations, especially when working in machine learning and deep learning models, like you see here, scikit-learn, TensorFlow, for lower memory usage, and when you don't need to have labels or indexes, and we're mainly working with numerical values. And Pandas is more for working with tabular data in general. It's like we're working with SQL or with Excel. It's good for filtering, sorting, grouping. It has a good readability, and usually you'll use them both in your work as a data analyst or data scientist especially. So we can see here, for most use cases like working with tabular data, you'll have Pandas. Math or statistics, you can use NumPy. Machine learning models, you will use NumPy. And that's the power of NumPy. You have Pandas for structure and NumPy for numerical calculations and speed. So I will put this on the GitHub. I will put it in the description below. I hope you enjoyed it. If you have any questions, please leave them in the comment section below. If you have any suggestion of projects or things that you want me to cover next, just pop them also in the comment below. And if you want to see this in action in a real world project, I recently worked on a football data set to predict the next La Liga winner. Is it going to be Real Madrid or Barcelona? We don't know, but we can predict that, and that's what I did. And if you want to have a look, you'll find the video just here. You can go and watch it next.